y is equal to negative 3x cubed plus 9x. Determine the turning points and whether they are local maxima or minima. First of all, piece of paper, don't tell me what to do. If you're going to insist on telling me what to do, a simple please would be nice. Okay, that's better. I think 3 question marks would have been more appropriate. But what we need to do is we're trying to find the turning points. And remember, the turning points is when your gradient is at 0. So it's going to go straight across. It's going to be horizontal. You want to start with the first derivative. Please pause the video and find the first derivative. And here is the first derivative. I made a little error here, so please ignore the tape. I try to cover it up. But here we go. And remember, we're trying to find the turning point. So we're going to put 0 in for y, because your gradient at a turning point is at the top or the bottom of a curve. And that's where your gradient is 0. Let's go ahead and advance. I put 0 in, and I kind of skipped a step, but what happened between here and here was the -1 was divided. So it's easier to solve. So now we have a difference of squares, which we know how to do. So we get 3x plus 3, 3x minus 3. And now we can solve for x. So we get x is equal to 1 and -1. And now remember, when you have these, you're going to put them back into the original equation, which is here. Okay, so we're going to come back down here, and then we're going to proceed. So we put them back into the original equation. We're finding coordinates. Remember, coordinates are defined. They're in 2 dimensions, and they're defined by 2 variables, an x and a y. And the turning points are here. So 1, 6, 1, -6. And now we have to find whether or not they're local minima or local maxima. That's our next step. And this is a rule that I want you to remember. Now the second derivative is just the derivative of the first derivative. And 0, okay, so if the second derivative is greater than 0, then it's a local min. The reason why, if you're down here, well, let me just draw this for a minute. If you're down here, let's say, and you've got a cubic function, something like this. If you're here at the very bottom, then your gradient is gonna be higher than 0. Okay, so maybe remember it that way. If that doesn't make sense to you, just memorize it. And if you have a maximum, then you're here at 0, then your gradient is going to be less than 0. Okay, so let's proceed. And here we went ahead and found the second derivative. And the second derivative is the derivative of the first derivative. And let's go back. The first derivative is here. This. So we find the second derivative from that. And we found out for -1, it's greater than 0. And for +1, it's less than 0. Therefore, this is a local minimum. This is a local maximum. If we look at Desmos, we have -1, -6, and that's a local minimum. And 1, 6 is a local maximum.